morning. Welcome to one additional new lecture of sustainable manufacturing. Today we are going to discuss the topic basic modeling concepts for factory simulation. Remember that we talked about what is a model. One of the phrase that I want to recap today is model, and which we called it as an abstraction of a real system. Okay. So here what we are trying to abstract. What are we trying to abstract? For this course, we are trying to abstract a factory, or what we can call it as a production facility, and what are we trying to study of that? How to make it sustainable. And why are we doing this? Why are we doing this? Because experimenting or experimentation with a real factory is very expensive and almost impossible, because nobody will give you the entire factory to say, please go ahead, take my factory for the next 1 year, run the simulations, run the test and tell me how the factory to be made green. So that's the reason why we have to use simulation to do the study. And for that we talked about modeling. We studied about why is modeling necessary, why is simulation modeling is necessary. But we also now need to see how to make models of manufacturing systems, or what are the basic building blocks within which you can build complicated manufacturing system models, because at the end of the day you will have to model the factory no matter what. And for modeling that factory, you would end up using some of those stuff that we will be learning today to build that model. So, and I am Dr. Deepak Philip, and I am from IIT Kanpur. So today first we will talk about facility layouts and the concept of that. So the one most important thing that we try to do is the manufacturing process selection. Okay, and this concept is which process, what manufacturing process we will use. Remember, when we studied in the class, we said that the building blocks in this sustainability scenario is unit manufacturing processes. Okay. So most important thing is you have to decide which manufacturing process you are going to choose. What is the right process selection? So it is typically decided on the way the production of the goods will be organized. So how the process is organized, that question to a large extent determines the way the production of the goods will be organized. Okay. The major implications of this is, okay, what are the major consequences, or what all things do we need to consider? This is one important thing. The first one you need to think about is capacity planning. What capacity is needed, then what capacity is possible. Okay. Remember, capacity, this particular thing, is a luxury actually. You would like to have infinite capacity, but capacity always comes up with a large cost. Okay. So the problem with the capacity is that capacity comes with large cost. Okay. So you can't really have infinite capacity because it will require infinite amount of money, which is very hard to raise. So in that regard, you have to decide how much capacity is needed and how much it can be actually created. That is both is taken into consideration. Then comes the layout of facilities, the second one. How is the question here is how is the facility or factory, whatever you want to call it, okay, how is the facility or factory laid out, okay, do we have space, okay, can a particular process be incorporated into this. All these are thought through as part of this, okay. Then comes the consideration, okay, what type of equipment or whether it can be equipment or labor intensive. So the two options here, if you say equipment intensive, then we are talking about more automation, okay, whereas labor intensive implies less automation, more human skill, okay. So you have to decide what you are going to do. So if you are in a handicraft business, you would probably be more labor intensive because it depends a lot on the human skills at that point. But if you are looking at producing a car or a mobile phone or something, then there will be a lot more automated equipments where you give the design of the part and as well as the production plan or the computer aided manufacturing code, CAM code, and then the machine pretty much manufactures it by itself, okay. So those such machines are sometimes called as CNC, computer numerical control machines, or digitally controlled machines. And the last aspect is design of work systems, okay. So here is like what or how the work system are designed, okay. That also is another aspect that is part of this, okay. So as you can say that the process selection of manufacturing process is a complicated thing because you have to consider capacity, you have to consider the layout, you have to see whether there is space available, you have to select you have to choose based on the type of equipment that you have, or do you want to do be more automation or less automation, and also depending upon what are the type of work systems that are available, okay. So all these factors goes into the design or choice of the manufacturing process. So the another part also is that you need to consider is the production decisions, what we talk about it as the production decisions. There is a hierarchy associated with it, okay. Once you set up a production facility and a process are set up, okay, once you have the factory and the process set up, a set of production planning decisions are required. So the sequence is this: set up factory, which means erect machines, okay. Then you have is the setup processes, okay. This is where what to do on which machine and how, okay, this part. Then from there you have to decide what to produce, okay. What are you going to produce, okay. So it is kind of a hierarchical, what you have to have factory before you set up the process, you have to have the process set up before you decide what to produce, and then you have to know what to produce, then you need to determine how much to produce, okay. After this comes the how much to produce, okay. So this process keeps on going hierarchically, it's one after another. So that's why the production planning is obviously always called as a hierarchical process. Hierarchical is it is a sequential top down approach, okay. And you cannot start decide how much to produce unless you have the factory set up, so that kind of a thing, okay. So that's one aspect of the production decision. Then there is another aspect is when you decide how much to produce, then you have to do is schedule the production, okay. Here we use the concept of operation scheduling. Okay. So, schedule the production means you have to decide which machine will produce how much at what time, that kind of a thing. So, that is typically called as operation scheduling. Okay. Operation scheduling, it is the allocation of resources over time to perform a collection of tasks. Okay. So, your resources, whatever you want to call it as, resources are allocated over time. Okay. So, you have a time going on here and you have multiple resources, they are allocated to different tasks. So, here you will have task 1 going on, task 2 going on, task 3 will be going on like this, task 4 going on like this, something like this. Okay. You have different processes, then task 5 will come after this here, okay, something like this. So, what we are trying to say is that these resources are allocated over time to perform a collection of tasks. So, the word collection means at this time period, if you take this as a particular time instant, if you take this, you can see that we are only doing the T4, this particular task. However, if you take this as a time instance, then you have these two we are working on. So, this is a collection. Okay. This particular time instant, you have all the three being worked on. So, that is another collection. Okay. So, depending upon what time you look into this process, you will end up deciding the set of tasks, which task you are going to work upon. Okay. So, this is the importance of operation scheduling. So, the operation scheduling comes in once you decide how much to produce, then you end up deciding how to schedule the production. So, as I said earlier, some of the definitions, you are like resource, what do you mean by resource? So, the examples of resource are workers, machines, tools, etc. So, workers, you can think about it as the manpower or the human beings associated with it, all right, or you can think about it as the skilled laborers. So, these are all terms that are used for the workers. Machines are the, you can think about it as drilling, lathe, milling, etc. So, all of these comes under the machine, under the machines. So, use machines, and then you can have tools where will be drill bit, coolant nozzle, etc. There are other jigs, fixtures, all these will come under the tools aspects of, broadly come under the tools aspects of the. So, all of these things are resources, because you require, it is allocation of resources over time to complete specific tasks. Okay. So, this is what we call as operation scheduling. So, this is what we are trying to allocate. You are trying to allocate workers, you are trying to allocate machines, you are trying to allocate tools over a time period, over a time horizon. Okay. So, here the concept, when we say over time, this implies a time horizon. We will come across this term, we will later call this as planning horizon, and we will discuss what it means is planning horizon. But it is what we are taking is, we are taking a specific unit of time, and then we are allocating these resources over that time period. Then similarly, another term that we talked about is this task. What are tasks? Examples of tasks. Okay. Task in a broad sense, they are operations, okay, that bring some physical changes to the material in order to eventually manufacture products. So, you have a raw material, okay, this is raw material, and then it goes to what we call as a transformation process. Okay. Then you get a finished good. This is a simple thing. So, this transformation process is where the operations happen. Okay. Operations. So, this raw material, some physical changes are made to the material. The material here implies raw material. Okay. So, this is the raw material. So, raw material is changed, some physical change, or raw material, the shape, quantity, size, etc. are modified. Okay, this is all done. Okay, modified through operations to eventually manufacture the product. Okay, so the operations might result in, so one sequence will be raw material. Okay, transformation process 1, you get a sub assembly. Okay, we'll go to another assembly process 2 and get a finished good, something like this. So eventually somewhere down the road you will get the finished good. That's the idea. Okay, so operations, again, it is one that bring the physical change to the raw material in order to eventually manufacture the final finished good or the product. So that's one example of task. Another one is setup task. These include walking to reach the workplace. Okay, so if you think about a factory, if you look from the factory from the top view, and let's say you have a, this is your drilling machine 1, and here is your toolbox. Okay, so the human being, he walks to the drilling machine, then walk to the toolbox and walks back this much. Okay, obtaining and returning tools. Okay, these are all part of the setups. So these are all setups. Okay, let's say you have a collection of jigs here, so then this person walks from here to get the jigs and walk back. That's also, then that is one other example. Picking up and setting the required jigs and fixtures is an example. Loading the job onto the jig and fixture is another example. Positioning and inspecting material, then cleaning the workspace, all of these things are setups. So setups, in another way to think about it, is all activities that lead towards realizing the operation. Okay, or what we can call it, or the transformation process, either one, we can call it that way. So these activities, setups, need to be done before you can start. So you have to load the workpiece onto the machine before you can start machining. But before you can load the machine, load the workpiece onto the fixture, you have to go get the fixture, and before that you have to come to the machine, clean the machine, set up the machine, all those kind of things. So all these setups are tasks that are precursor before the actual operation or the transformation process begins. Okay. Now we talk about, in manufacturing, one other term that is heavily used is operations and job. Okay, so people sometimes use this term task, and then there is job. Many a time people kind of use this interchangeably, but that's different. Actually, both are quite different. The task, it is a more general term. So task is a general term. Is a general term. Why is it a general term? Because it includes both operations and setup. Okay. So here in a task you have the raw material, resource, operations, setup. Okay, all these things are considered as part of the task. Okay, it's a more broader term. Okay, so in the operation side, whenever we think about it, is we usually use the term job, okay, instead of the term task. The difference between a job and a task is that task is a general term which includes both operations and setups for anything, very broad, whereas for if you are taking a single product and all the collection of operations that are necessary for the single product, it becomes a job. So collection of operations for a single product, it becomes a job. The confusion usually happens between task and job is where, because the example that is used to study task and job usually is a single machine, so in which the task and job can be used interchangeably, because each task is a job actually. Whereas in the case of a factory where you are going from multiple machines, so whichever you are producing, that determines whether it's a task or a job, depending upon the. So you are, let's say in an automotive company, you are manufacturing two type of cars. Let's take Maruti Suzuki as an example. All the operations that are required to produce like Maruti 800 will be one job, or you can think about as all the operations that's required to produce Maruti Baleno is another job. So it is for a single product, whatever the collection of operations that are required. So that is the distinction between task and job. So the task versus job. This is a broad term. This is per single product. Okay. This is collection of operations. So when you have a task and a job, then we talk about the term called a schedule. Some people call this as a production schedule also. Okay. Let's not worry about production schedule for the time being. Let's just talk about the term schedule. What is a schedule? It's a schedule is the final outcome of operation scheduling. Okay. And it gives a detailed chart of what activities will be done using various resources over the planning horizon. So here comes the word planning horizon. So if you have a time period T, and then you are going to determine what all operations, okay, what all operations will be done using which all resources, okay, and you make a chart of it, a detailed chart of it, then that becomes a schedule. So one chart will be like at 10 a.m. to 10:30, okay, a.m. start drilling, okay, or drilling of 10 holes or whatever it is. 10:30 a.m. to 10:39 a.m. Remove workpiece, okay. Then 10:39 a.m. to 12 noon. Okay. So something else, and remove workpiece. You'll say John will remove this workpiece, something like that. So here you are assigning the drilling of 10 holes, drill machine 3. So we'll say, okay, we are using drilling machine 3 to drill 10 holes on a workpiece at 10 a.m. to 10:30 a.m. Then after that, John will come and remove this workpiece from the machine. It will take 9 minutes for him to do that. Then after that, 10:39 to 12, you will do something else on the workpiece, on grinding or something like that, using grinding machine 2 or something like this. Okay. So you have a detailed chart. It's a chart. There is a time. The chart will tell you the time sequence of what activity will be done at what time, okay, and which resource will be used for that. So the planning horizon, what we talk about this time, what we talk about the planning horizon of schedule, okay, scheduling decision or a schedule, okay, the planning horizon of a schedule is very short usually, okay. You either do planning worth of days or weeks, at the max a month, okay. So you typically go in 24 hours or 48 hours or something like this, okay, or you might go to 5 days week or 7-day week, something like this, or you will go into a 30-day month, something like this. Rarely we go to that long of a duration. We usually play within days and weeks. You don't take the plan, you don't do the production scheduling for huge long time period. You can have like a rough schedule, but the actual schedule is done for very short time period. The time period is usually short, that we need to remember, okay. So with that basic concepts ready, we will go into the next one of the production systems, because we also need to know some details about what is a production system. And I know many of you have studied this, many of you have absolutely no clue what it is. So we will try to give an overview of this, and I would recommend you guys to read a little bit more on these ones, on what's a production system and stuff like that. And there is one book that is very famous for this. It is Production and Operations Management, a systems approach, I believe is still there in the title, but it is by Russell and Taylor. This is a book that will give you a lot of the fundamentals on the various production systems and the importance of those things. So, I would recommend you guys to read this book as a part of the problem. Okay. So, this is a recommended reading. All right. Okay. So, the production systems, as we said earlier, it's a, you have a black box called transformation process. And here you get the finished good, here you get the raw material. Raw material goes into the transformation process to get the finished goods. So, the transformation process, depending upon the product that you are going to produce, okay, the product that is chosen to some extent, not some extent, to large extent actually, okay, large extent, determines the production system, or what we are talking here is the product characteristics requires different production systems. Depending upon the characteristics of the product, okay, this product characteristic, it to a large extent determines what the production system to use, what production system to use. Okay. So, standard products, when people talk about standard products, it is like, very automotive, those kind of things. Okay. Or like we talk about it as toothpaste, those kind of stuff. Okay. You do a make to stock production system where you actually produce in large quantities, and stock so that customer can buy when needed. So, it is unlike that you go to a shop and say, well, I need a toothpaste, and then they say, oh, you need a toothpaste, okay, give us an order, we will produce one and send it to you in like 10 days. Nobody does that. You go there, you pay the money, pick the toothpaste, go home. So, the make to stock system, which is a standard product, toothpaste is a standard product, everybody knows, okay, go buy the toothpaste, whichever one you like. So, that is a situation where they produce and stock and people just buy and use it. Okay. So, there the productions is large volume, quite large quantity, and you make it and stock it with you. Okay. Whereas the custom products, the other hand, is a different story. Custom products, they pretty much make a make to order or an assemble to order production system. An example of this is high end cars like Rolls Royce. Okay. They don't make Rolls Royce and just keep it on the shop floor like so here you can think about Maruti 800 is a make to stock system, whereas a Rolls Royce Phantom is definitely not a make to stock, it is a make to order. So, you go there and say I want to buy a Rolls Royce, then they will say fine, what are your specifications, what is your color, what type of leather, what should be the engine stuff, okay, what are the other paraphernalia you need, do you need a refrigerator, okay, do you need iPad, all those kind of weird things. You will probably get like thousands of choices, and you pay all those thousands of choices, you pay the money, calculate whatever it is, you pay the money, and then you wait because then once you pay the money, then the production starts. Okay. So, once customer pays, the production begins. Okay. These are meant for highly customized products. It is per the discretion of the customer. It is not a standard product. Okay. So, obviously, the main difference between custom products and standard products are custom products are usually very expensive when compared with standard products. For example, you could get maybe a Maruti 800 or something. Now I don't think they don't no longer make Maruti 800. I think it's Alto or something like this. You will get for 2 to 3 lakhs, whereas at Rolls Royce it will run to 2 to 5 crores. Okay, that will be the difference. Okay, so custom products are usually more expensive, and depending upon what you are trying to make, whether you're trying to make a custom product or a standard product, your production system decisions will change. So the production types from the operation scheduling angle, mostly when we talk about processes, when we are trying to do the operation scheduling or when we are trying to build the factory model, okay, we need to look into these aspects. The number one we look into is a single machine, then the parallel machines, floor shop, job shop, fixed position assembly. So this we will not spend too much time on this, because this is more like, you know, aircraft manufacturing or shipbuilding or construction, etc. The major thing here is that the product remains stationary and resources move to the product. Okay, so the man, materials, machine, methods, everything, all these move to the product and product remains stationary, whereas these guys, the resources remain stationary and product moves to various machines to get processed. So that's the major difference between these two setups. So here you are saying that you are going to build this building, something like this. Okay, and you have a building. So the wood, windows, all those kind of things will move to this place, wherever it is. The bricks, the cement, everything moves to this, because you can't really, it's not really very easy to move a big building like this. So this is a fixed position layout, whereas in this case you have various machines lined out like this, and the products moves from one machine to another, so that at the end it starts with the raw material and comes as a finished good. Okay, so the idea so what we are going to look into in this course is mostly these aspects, because these are the ones that creates what you call as a factory like setup. Okay, so it is imperative for us that we learn what are these things in a much better fashion. Okay, so we will take one by one and then go from there. So the first one we will talk about is a single machine system, which is the building block. Okay, single machine system, you can think about it as, can be thought as the building block. Okay, which means all unit manufacturing process can be modeled as single machine. So if you think about it in a schematic fashion, a single machine system is something like this. You have a machine. This machine could be anything. It could be, you know, it can be a drill, a mill, grind, plane, whatever you want to call it. Okay, there are many, any of them can be modeled like this way. Okay, and then what you have is, you have parts or raw material or tasks or jobs, either one, all of these things you can call whichever way you want to call it. We'll talk about much more detail. And they come in to this machine and they come and wait. So this is individual parts waiting. Okay, and then when the machine is free, okay, it gets processed, and then the finished good moves out of the machine. So, the major aspects of this is the parts arrive, okay, they wait in a queue, then they get processed or machined, and then they leave. Okay. So, there are a couple of aspects that we need to look into this. So, the place where the parts are waiting, this is typically called as a queue. The concept of queuing gets used in any manufacturing. So, this queue, if you have too many parts waiting here, then that is also called as not good to have a large queue, because it will take up space, take up precious factory floor. Okay. So, this kind of lot of items waiting there, this is also sometimes called as work in process inventory, or commonly known as WIP, WIP. Okay. So, the parts they come, the another concept is the arrive. Okay. Arrive means the rate at which parts or jobs come to the machine. So, if I say that one part in every 10 minutes is an equivalent arrival rate of 6 per hour. So, I will say that the parts arrive at the facility at the rate of 6 per hour. So, this is called as the arrival rate. Okay. So, this determines how quickly, so every 10 minutes you get a part. Okay. So, now the other one is the process. Okay. Process, or what we call as, you can think about as service. Okay. Process or service. What happens is the rate at which the jobs are processed by the machine. This case, this is called the machine. So, I will say that, I can say one part is processed in every 6 minutes. If I say that, I can say that I can pretty much do what, 10 per hour. Okay. So, this is called as this 10 per hour is called as the service rate. Okay. So, if your service rate, okay, is higher than arrival rate, so ideally what happens, you only take 6 minutes to process something and parts arrive in every 10 minutes. So, if you look at it at time t equal to 0, one part arrives, okay, part arrive, machine is free. So, immediately t equal to 0, process part, t equal to 6, finish process, then t equal to 10, next part arrive. This means there is 4 minutes of the time where the machine is idle. Okay. Idle time. So, the concept of idle means the machine is not doing anything. Okay. It is staying not doing any job. So, the concept of idle time is also part of this. So, the arrival rate, the rate at which the parts arrive to the system, the service rate or the processing rate, the rate at which it actually processes, those kind of things. So, one other aspect also is that you can say that, okay, fine, there is also something called as a setup time. Okay. You can consider it separately. So, you can basically say that, okay, it takes 2 minutes to process, to set up. Okay. So, then you can think about here, it will be like parts arrive, t equal to 0, instead of process it will be setup part, and t equal to 2, start process, then t equal to 8, finish process, then you have an idle time of 2. So, these kind of concepts. So, the understanding these aspects of a production system, the single machine is the best way to go with it. Okay. So, the concept whichever it is, even if it is multiple machines, the arrival is a phenomena that we need to model. At what rate the parts or the raw materials arrive into the system, that is the first thing. Second one is the service rate or the processing rate. The rate at which, what is the rate at which we can process the parts that have arrived at the system. Okay, that part. Then comes the setup, how much setup time is required for that. Then once you know the, so if these times were the other way around, if the arrival rate was let us say 10 per hour and service rate was 6 per hour, then you will get something called as a queue. Then queue happens. Then aspects of the queue like length of queue, average waiting time, time in the queue, all these aspects are studied at that point. Okay. So, this is the concept. The basic single machine allows you to model the unit manufacturing processes, as I said earlier, and it allows you to study the various aspects of the system. So, in this, if you can measure out what is the processing time clearly, then you can calculate energy as well. Okay. So, you might now get an idea that by breaking down the entire factory into unit manufacturing processes, we would be able to measure finer aspects of the system. Okay. So, then obviously, if you there is one machine, there can be multiple machines also. So, in one setup, parallel machines. Another setup that we talk about is where multiple machines are arranged in parallel. Okay. So, here an example would be, this is a machine 1, machine 2, machine 3, like this, and each machine has its own queue. So, M1 queue, M2 queue, M3 queue, and the products come out of this. Okay. This is also another setup. So, the parts arrive here. Okay. And then they get processed. Here, say various aspects you can consider is each machine is unique and hence has separate processing times or rates and arrival rates. Okay. So, that means the queues, which means each queue will be different. Okay. It can also be a situation where you can say that all machines, another option, all machines can be identical also. Okay. So, that means processing rates, arrival time, arrival rates, all same. Setup time, these are all part of, they are all same. So, this kind of a setup is called as identical parallel machines. Okay. This setup what we just discussed is called as not identical, is separate parallel. This can also be called as non-identical. parallel machines, right. So, if you look into this, we would have a scenario you can study again. It's, you can see this by in itself is a single machine concept. Okay. So, here is a bunch of single machines arranged in parallel. That is one way to look into this. Okay. All right. So, now after this we will look into the concepts of flow shop and job shop, but I think what we will do is we will take a short break here and then we will join for the rest of the session. Thank you.